This is the 4.6 podcast, which is going to talk about how far an object falls in free fall. And last podcast we talked about how fast an object falls in free fall. So for each second of free fall, an object falls a greater distance than it did the last second in free fall. How far does an object fall in free fall in the first second? Well, the object's going to have an instantaneous speed, we said, of 10 meters per second. And the initial speed is going to be 0 meters per second. So that means its average speed is going to be 5 meters per second. And we can find the distance it travels by using velocity equals distance over time. So if it falls for an average speed of 5 meters per second in its first second, it's going to fall a distance of 5 meters. An odometer would be, if we could do this with a rock, we'd put an odometer on it, and the odometer would actually count how far the object's fallen, and we're going to see that it's going to increase with time. As time goes on, the object's going to fall farther and farther each second. So at the end of 1 second, the rock's fallen 5 meters. At the end of 2 seconds, it's going to drop a total distance of 20 meters. And if you look at this, velocity equals distance over time. We're going to say our velocity should be 10 meters per second. In that average velocity should be 10 meters per second. Our distance we're trying to solve for, our time is 2 seconds, and you can see if you multiply 2 times 10 meters per second, you're going to end up with a total of 20 meters. At the end of 3 seconds, it's going to be 45 meters, and this is forming a mathematical pattern. The mathematical pattern follows this equation right here. Distance equals 1/2 times the acceleration due to gravity times the time squared. If you put numbers into that equation, d equals 1/2 gt squared here, you get the following numbers: 5, 20, 45, 80, 125, corresponding to the first 5 seconds of free fall. These numbers pretty much you will have memorized because you're going to be using them over and over again in this chapter. So when we're talking about free falling objects here, but what if we apply it to any accelerating object? It doesn't. The same two equations are going to hold true. This one you recognize as v equals g times d, and here we've replaced the acceleration due to gravity, which is the general letter a, and the distance equation still works. It's 1/2 at squared, where we replace g with a. This, once again, is for any accelerating object where the acceleration is constant, and and the initial speed is 0. There is a special equation that adds the initial speed into it. So let's think about this. An apple drops from a tree and hits the ground in 1 second. What is its speed upon striking the ground? What is its average speed during 1 second? How high above the ground was the apple when it first dropped? Well, we know the first one. It's going to be 10 meters per second. We said that an object accelerates at 10 meters per second for every second. So after 1 second, it should gain 10 meters per second. The average speed is 0 plus 10 meters per second divided by 2, so we end up with 5 meters per second. And we found that the object drops 5 meters from that height. If you use d equals 1/2 gt squared, you'll come up with 5 meters. So for a falling object, how does the distance per second change? For each second of free fall, an object falls a greater distance than it did in the previous second.